Hello and welcome. This is a continuation of the RPN calculator. When last we left, we had just locked down the API to the calculator. So now, rather than calling add, subtract, multiply, divide, etc., consumer is going to use just a single method, execute. That keeps the API under control and allows me to work on the internals of the class without breaking clients. That's a substantial improvement in my opinion. There isn't a cost, as with any change is going to introduce problems. So I have this untyped thing where I'm passing in a string as opposed to calling a direct method, so there's a possibility of it being used incorrectly. I accept that though. What I want to do now is I want to take these method bodies and make them their own little classes so that later on to add new behavior to the calculator I'll add a new class to a subclass to an interface as opposed to adding functionality into the existing calculator. Again, we're moving towards removing duplication, but it's a bit of a process. I want to point out though that my tests are compiling and running. Actually, all my code is compiling and my tests are passing. So at this point, worst case scenario, someone interrupted me, I go work on something else, I come back, I'm green still. So let's go ahead and I'm going to turn this into its own little function object. I'm moving towards a strategy pattern. So let's create a new class here. Call it add. I'll create the interface after I've created an example of a class. Okay, so public void, I guess execute. I'm not sure what I'm going to put here yet, so let's go ahead and put the method body in. Okay, it looks like it needs values. I wonder, can I do this? There we go. Not bad, except that it needs to be an operand stack. Alright, so there's add. Now, given any operator, I don't know how many input parameters it needs or how many output parameters it needs. For example, sure, add and subtract are binary. They need 1, 2. Factorial is unary. When you use a strategy pattern, you don't have a bunch of methods on the strategy pattern and then you do a switch to figure out which one to call. That's not the strategy pattern. The strategy pattern, you traditionally are going to have one method to call, something like execute, operate, or do, or something. So I'm going to call it execute. It's going to pass in values. As written, I think this will work. So let's find out. Let's see. I've updated add. So I guess new add execute values. Went a little too far there, it looks like. All right. Okay, everything's passing. That's just some visual noise from Eclipse, so I'm going to go ahead and close up Eclipse for just a second. I'll close up that file and... Alright, well... Okay, so I've got add working. I'm going to do the same thing for subtract. So let's go ahead and do the exact same thing for before I do subtract, though. Let's be a little bit smarter about this. I want to use the refactoring tool, so let's refactor, and I'm going to extract an interface. Now, I want to have a common interface. So this is necessary for languages like C++, Java, and C#. Wouldn't be necessary for something like Smalltalk or even Objective-C, really, or Ruby, for example. But for what I'm doing, the way I'm approaching this problem here, I'm going to need to use an interface. I guess I'll call this math operator. All that did was change add to implement the math operator. Okay, great. So now, when I copy subtract, I'm going to create a new subclass of that new interface. So let's see, new class, subtract, and it's going to implement math operator. Okay, so now let's see if that works. Okay, and do the test pass. Excellent, test pass. That was pretty quick. Same thing for factorial. All right. So new class, factorial, and I'll add math operator. save it, use it back here. All right, let's see if the tests pass. Okay, great. Now that I've done that, I'm going to go ahead and refactor, and I'm just going to inline this code because it's not really doing enough to it's not really adding any value in my opinion. Okay, great. Now I can get rid of these methods altogether. Okay, now let's see what happens when I run my tests. Alright, excellent. Okay, this is a good start, but we're not quite there yet. This individual method violates the single responsibility principle for a couple reasons. It needs changing how I add a new operator. That's one thing. But it just exists at multiple levels of extraction. And it's doing two fundamentally different things. Selection of what to do and execution. Alright, so I'm going to go ahead and I'm going to change this up a little bit. So math operator op. Okay, so far so good. And then I'll do, because I'll implement a similar interface, I can get away with that. Now, does that work? Okay, great. Now I've done this. This whole block of code is doing something illogical. It's actually logical, not illogical. It's actually doing some kind of factory work. So I'm going to head and extract that. So I'll refactor that and extract that as its own method. All right. So now, find operator named and execute. There we go. That's pretty good. I think I can simplify this now. Test still pass? Okay, great. That's better. So now, we still have this problem here, but again, I'm pushing it further and further off until I'm going to get to the point where I have to actually do the full-blown abstract factory and so on. So this is the next step in the process. What I want to do next is I want to remove the duplication between add and subtract. So that's what's going to happen next. We're finally going to get to the point where we remove the duplication between add and subtract. Then we're going to come back and revisit this little problem here. And after that, we'll start looking at adding some new functionality.